Hello everyone, in this video we're going to be talking more about similarity within triangles, mainly the triangle proportionality theorem, also called the side splitter theorem. And it basically says if we have a line that's parallel to a side in a triangle, and that line intersects the other two sides, it's going to divide those two sides proportionally. So this is why it's called the side splitter, because it splits the sides proportionally. All right, so like if TU is parallel to QS, that's what those arrows mean on those line segments, then the ratio RT to TQ, the top part over the bottom part of one side, is going to equal the top part over the bottom part of the other side. It's going to split those sides proportionally. Okay? And then the converse of that, the flippity flop, says that if a line divides two sides of a triangle proportionally, then it has to be parallel to the third side. So if these two sides are divided proportionally, then we know that TU will need to be parallel to QS. Okay? That has to be there. You have to have parallel lines to split the sides proportionally. So how does this help us solve for missing side lengths? Well, if we wanted to solve for the length of QU, so this part right here, I'm just going to call this X. We'll notice how the line inside the triangle is parallel to the third side. So I can set up a proportion here. On the left-hand side, I've got 10 over X, the top part over the bottom part. And on the right-hand side, I've got 12 over 6, top part over the bottom part. Cross multiply and solve. So we're going to get 60 equals 12x if we cross multiply. So x is going to equal 5. What was x? X was QU. So QU equals 5. Okay? And this comes from the fact that, remember, if a line inside the triangle parallel to the third side, it's going to make two similar triangles because they share this top angle, in this instance angle R, and you've got corresponding angles here. All right, and remember, we only need to show that two angles are congruent. Angle similarity. All right, so I'm going to erase this third one just because we just don't need to know all three angles. We just need to know two of the angles match up. Okay? And that's going to help us because then we can set up those proportions either by the triangles or by the side splitter. Okay, so we could do the side splitter, which is going to be RT over TQ equals RU over US. Or if we looked at those two triangles separately, we could do the small side, RT over RQ, the whole side, equals RU over RS. Okay, there's a couple different proportions that we can set up here. We can look at it as similar triangles and match up those corresponding side lengths, or because that parallel line inside the triangle splits the sides proportionally, we could do part over part equals part over part. All right, so let's look at example B. If PA equals Y, so PA equals Y, AQ, let me get a different color here, AQ is equal to 4, AB is equal to 12, so now we're talking about this side length in here, AB equals 12, QR is 20. Okay, well that's different, because the parallel line splits the sides proportionally, but I don't know anything about the sides over here. Instead, we want to use this concept of similar triangles, and what might be helpful is if I draw those triangles separately. So this top triangle, triangle PAB, has PA as Y and AB as 12. And the big triangle, PQR, has this left side length, and if I want to figure out what PQ is, I need to add those two parts together. Part plus part equals whole. and the bottom part is 20. Now I can match up corresponding parts. So you need to be careful and make sure you label your diagram correctly so that you can match up the correct corresponding parts. The side splitter theorem doesn't work here because the parallel line splits the sides proportionally, but we don't have both of those sides. We've got the line inside the triangle and the third side. So that's going to be the similar triangle setup. Now we can match up corresponding parts. Y over y plus 4 equals 12 over 20. So there's our proportion. Cross multiply, so we get 20y equals 12 times all of y plus 4. Distribute the 12, so I'm going to get 20y equals 12y plus 48. Subtract 12 from both sides, so we get 8y equals 48. So y will equal 6. Okay? So make sure you pay attention to that one because that's a good quiz or test question. Because I do not want, and let's make sure we understand this, I do not want y over 4 equals 12 over 20. Okay? These two ratios will not equal each other because this belongs to the top triangle, 4 belongs to the bottom part, and 20 belongs to the big triangle. All right, so there aren't corresponding parts. Everything's not matching up in our proportion. So this right here is a big no-no. Okay, that's not what we want. That's not what we want here. So make sure, draw your separate diagram because that's going to help you match parts up. Okay, last little concept for this is 3 parallel lines and 2 transversals. So this is going to work very similarly. If we have 3 parallel lines intersecting 2 transversals, they divide the transversals, you guessed it, proportionally. All right, so WX here, this middle parallel line, is going to divide the sides proportionally. So UW over WY is going to equal VX over XZ. All right, so if we have a situation like example 2, a farmer's land is divided by a newly constructed interstate. The distance shown is in meters. Find the distance CA. So I'm trying to find this entire distance between the north border and the south border. Okay, well, this parallel line BE is dividing the sides proportionally. So I can set up a proportion with the top part being 2,000. The bottom part, this BC, I don't know. So I'm going to call that X equals the top part of the other transversal, which is 2,500, over the bottom part, which is 3,000. Okay? So, now when I cross multiply, 2,000 times 3,000 divided by 2,500, X is going to equal 2,400. But remember, this is just BC, so BC is 2,400. We are trying to find CA. So I need to take, if I'm trying to find CA, I need to take the 2,400, which is BC, and I need to add the 2,000, which is AB, and I will get that CA is 4,400 meters. All right, that's one way that we could set up our problem. All right, another way, and I'm just going to scooch this over smaller, just to show you the other way. All right, the other way is what if we called this y? What if we called the entire AC y? Well, then we could do the top part over the whole of one transversal equals the top part over the whole of the other part. So if I cross multiply here, y is going to equal 4,400. So you're going to get the same exact answer. It's just your final answer is it. There's nothing else you have to do to it. All right, so there's going to be several different ways that you can set up these problems just because of the proportions that you're dealing with. Just make sure what you're setting up has the corresponding parts matching up. So like in this first way we did it, my numerators were the top part, my denominators were the bottom part. In this second proportion we set up, the numerators were the top part. The denominators were the whole segment. So we have those corresponding parts that match up as I look across my proportion. All right, so there's going to be different ways to solve these. Just make sure you're matching up the correct parts. So you got 4 you try now problems. Try those on your own. 2, I think the types is just hard to see. So both those numbers are going to be 38s. And then we got an 18 as PQ and an 80 as TS. All right, so try those 4 you try now problems. I will have the workout on the filled out notes available online. Okay, let me know if you have any questions. Make sure to get these done and practice, practice, practice.